Hello and good day again, starting with CO45, talking about all the different properties and characteristics of a parallelogram. A parallelogram is probably a shape that you've heard before. In fact, I know it's a shape you've heard of before, but what is it? What makes a parallelogram a parallelogram? Gabby?
The sides of the shape are all parallel to each other?
Okay, well, they can't all be parallel to each other, but yes. A parallelogram, both pairs of opposite sides are parallel. Okay? At its core, that is what a parallelogram is. Any four-sided shape that has both pairs of opposite sides marked as parallel is going to be a parallelogram. And we're going to talk about a whole bunch of different kinds of shapes that fall under this category. But before we start, I want to make sure you understand that you know what the... Oh, that is horrible. Oh man, I wish I knew how to edit these things. That would be out. I want to make sure that you understand exactly what the parallel symbol looks like. I think we've talked about it before, but it's like an arrow going through the sides. If you would see that, that would show you that that pair of sides are parallel. If you have a second pair of parallel lines, you would use two arrows going through it. Okay, so that's how you would mark that both pairs of opposite sides are parallel. Right? Other characteristics of quadrilaterals that are parallelograms. Theorem 8.3. Both pairs of opposite sides are congruent. Okay? Both pairs of opposite sides are congruent. If you come across a quadrilateral, a four-sided shape that is marked with both of its opposite sides as congruent, you are dealing with a parallelogram, even if they're not marked parallel. Okay, this is one of those characteristics to where if they're both marked congruent, a four-sided shape, then by definition, they're also going to be parallel sides, thus making it a parallelogram. Okay? Theorem 8.4. A parallelogram will have both pairs of opposite angles congruent. Both pairs of opposite angles will be congruent. So if you come across a four-sided shape that has opposite angles marked as congruent, you know you're dealing with a parallelogram. You know the opposite sides are congruent as well. Opposite sides are parallel. It all falls under the same category. Okay? Questions so far? Good. All right. Theorem. What? Good? All right. Theorem 8.5. Also dealing with the angles. Consecutive angles in a parallelogram are supplementary. So we have the opposite angles are going to be congruent. The consecutive angles are going to be supplementary. So you've got a four-sided shape. We'll label each pair of congruent angles. First pair will be X. Second pair will mark Y. And if this is a parallelogram, then X plus Y will equal 180. Okay, that word supplementary goes all the way back to PO7 in Unit 1. It means that the angles add to be 180 degrees. And so there we have it there. Okay. Theorem 8.6 has to do with the diagonals the diagonals of a parallelogram will bisect each other. The diagonals of a parallelogram will bisect each other. Meaning that you've got your four-sided quadrilateral here. The diagonals, as we learned previously, there are only two that can be drawn in a quadrilateral, right? So there's only one vertex that's not adjacent to anyone that you start with. So our two diagonals are here, and by saying they're going to bisect each other, it means that this section, if we kind of make this point A here, is going to be congruent to this section here. And in the other one, you've got congruent sections there and there. So they bisect each other. Yes, Daniel.
Is that A like
We could, I suppose it would make more sense to call it M for midpoint, but essentially yes. Their point of intersection is the midpoint of each diagonal. Okay. Questions so far? All right. Theorem 8.9 kind of combines the first two that we talked about. If one pair of opposite sides is congruent and parallel. Boys, I can hear you talking up here. You're not doing a very good job of hiding your side conversations well at all. Okay? If one pair of opposite sides is congruent and parallel. So our first two theorems, we talked about both sides being parallel, both pairs of opposite sides being parallel. In the next one, we talked about both pairs of opposite sides being congruent. If you've got one pair of opposite sides marked both congruent and parallel, you know it's a parallelogram, and all these other properties, all these other characteristics also exist. Okay? So it's kind of the combo platter of those first two. Both sides parallel, or both sides congruent, or one pair marked both congruent and parallel. Okay? Daniel.
so when you say that they mark congruent and parallel, it applies for all of the theorems?
Yes, if one pair of opposite sides is marked both congruent and parallel, then you know their opposite angles will be congruent. Consecutive angles are supplementary. Diagonals will bisect each other. It is a parallelogram. Okay, so lots of different ways to classify a shape as a parallelogram. Okay, your homework for Thursday. You don't have to do it tonight. I'm just assigning it today. Okay, fine. Homework to be assigned tomorrow, due Sunday, is going to be page 511. Because homework is due at the beginning of each new week, because you're taking two math classes at once. I know you've got a lot going on, so you don't have to do it tonight. If you want to do it tonight, you get it done, you can. But yes, Brent. 511. Numbers 11 through 16. Well, hold on. Let me. 7 through 16. You show it to me at our next class next week. And then page 518. Page 518, I would like you to do 3 through 11. Mm,
Yeah, no more.
oh, I gotta give you a little bit more.
That's not even.
3 through 11 and 13 to 15.
Wow. That is not even.
Okay. Page 511 has to do with interior and exterior angles. Page 518 has to do with these theorems for classifying polygons as parallelograms. That's it, math, folks.